Hey future coders, welcome back to Programming with Swift Playgrounds. Now in this video we're going to learn about conditional code. How do you plan for something that was unexpected? You see, when you go on a trip and you hit a traffic jam, you may need to change the path that you use. Sometimes you need to take a detour. In code, you plan for these different situations by using what's called an if statement. If the light is green, you can walk across the street. To write an if statement, you start off with if, and then you add your condition. Here, it's light is green. And remember that this statement can be either true or false. If it's true, the code goes into the body and executes or runs the command. Here, it's move forward. If the condition is false, you can also use an else to specify other code to run. So here, if light is green, open bracket, move forward. Otherwise or else, just wait. So let's jump into it and start coding. Now in this puzzle we want to check for switches. So we need to move along each tile, and if there's a switch we need to see if it's on or off. If it's off or closed, we want to toggle it on and then move on to the next switch and test again. So you can see here all the switches are off, but if I click Run My Code, check out what happens. Aha! Did you see what happened? The first tile turned on. And if I run it again, now you can see that the middle tile is turned on. So all the tiles are randomly turned on or off. That is why we need to use an if statement. So, where do we start? Can you guess? If you said move forward 2 times, you'd be right. Let's go ahead and move forward 2 times to get to the tile with the first switch. And what should we do? Let's use an if statement, just like the example up above. Let's go if is on closed, open bracket, toggle the switch. Let's run this step by step to see how it works. Move forward, move forward. If it's closed, toggle the switch. Great stuff. Now we want to move forward again and test the tile once more. So let's copy this code above, Apple C, Apple V, and step through the code again. Notice how the tiles are randomly chosen to be on or off. Now we test the switch, it's closed, move forward, we're testing the switch, but because this is already on, we ignore it. Now let's copy this code again. We move forward and have the if statement again. So you can see we're testing 3 times here actually. And let's run through the code normally. Here, the first 2 tiles are already turned on, so we ignore it. Move to the last one, toggle it, and we solve the puzzle. Congratulations, you've just written code that works, even when you don't know how each switch is toggled on or off. And this is really powerful. Now, before we jump on to the next challenge, you may have noticed something here. We've actually repeated the code 3 times. Now, if you remember from our previous challenges, we could actually put this into what? A for loop and run it 3 times. We won't do that now, but we will be using for loops in the coming challenges. So let's now jump on to the next page. In this puzzle, we're going to learn about using else if. Now, to understand why, at the moment we've got two switches. Let's run the code before we start to see what happens. Check out this wireframe, the white lines. Now we've got two gems. Let me run the code again. Now we've got one gem and one switch. So what this means is when we move forward, we have to test. Is it a switch? If it is, toggle it on. Or else, if it's a gem, collect it. So that's why we need to use an else if statement. So to show you how this works, let's look at the example up here and we'll copy it. Let's enter the code where we first of all move forward and then we ask, well, if is on closed switch. If we're on a switch and it's closed, let's toggle the switch. Else, if we are on a gem, is on gem, then what should we do? Collect it. Exactly. So now let's go ahead and step through this code one by one. Here we go. Moving forward. Are we on a closed switch? No. So skip it. Go to the is on gem. Yes, it is. Collect the gem. Perfect. Do you know what we need to do next? We just repeat this code. So we want to move forward and then test the condition again. So as a shortcut, I can do a copy and paste and we'll step through the code. Move forward. Is it a closed switch? Yes. Toggle the switch. Move forward again. Is it a closed switch? Yes. Toggle the switch. And there we have it. Impressive stuff. So now you should know how to write an else if statement. It doesn't matter what's on the tile. It could be a closed switch, an on switch, a gem. You've got code to handle all the situations. Let's now move on to our next challenge. This challenge here may look tricky, but if we look closer, it's not that bad after all. Now, there are 12 tiles containing either a gem, a switch, or a portal. If there's a gem on a tile, we need to do what? We need to collect it, of course. If the switch is closed, what do? We toggle it open. And if there's a portal, we simply move forward. So if you look at the sample code here, you can see we have a for loop. Just like how we talked about earlier, we could repeat the same pattern over and over again. So let's go ahead and complete our first tile. We want to move forward and then we want to check if it's a switch or a gem. So just like in our last challenge, we said if is on closed switch, toggle the switch. Else if is on gem, let's collect the gem just like before. Now in our for loop, let's just make the number from 1 to 1 and we'll step through the code and test this out first. Here we go. Notice how we've got the wireframes. Here we're on a gem, we collect the gem and we stop. That's because we've only looped one time. Now if I change this number to say 2, let's try that again. Step through the code, move forward. Is it a switch? No. Is it a gem? Yes. Collect it. Move forward. Is the switch closed? Yes it is. Toggle the switch. Perfect. Let's now increase this to 6, shall we? And we'll run through the code a bit faster this time. Notice how the switches randomly change. Look at that. We've moved to the portal because you can see these last 3 switches were already open, so we didn't have to do anything. Let's now change this to 12 and see if we can solve the puzzle. Here we go, collecting the gem, skipping the switch, going through the portal, toggle the switch, and we'll collect all the remaining gems. There we go, future coders. Great work. We use the loop to reuse our code over and over again. Let's now move on to our next challenge. This puzzle here is called Conditional Climb. If you look at the puzzle carefully, you'll notice that when we reach the gem to collect, we need to do something. Can you guess what it is? That's right, we've got to turn left and walk up the stairs. Same with this gem and same with this gem here. So what it means is that after we collect a gem, we've got to turn left. So let's look at the condition here. We want to say if is on gem. If we're on a gem, we want to collect it. And then, just like we said, we want to turn left. Else, just move forward. So notice how we've got a loop from 1 to 16. Let's change this to, say, 4. And we'll run our code and we'll step through it. So now, are we on a gem? No, move forward. Loop again. Are we on a gem? No, move forward. Are we on a gem? No, move forward. Now, are we on a gem? Yes, collect it and then turn left. Now, all we have to do is increase the number of times we go through our loop. So if I change this to say the number 12, let's see what happens. We'll run the code through normally this time. Moving forward, collecting the gem and then turning left. Moving forward, collecting the gem, up the stairs. There we go. Now we need to find out what the last number is in our loop. So you might be thinking we need to loop 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times. But that's not correct because we've just looped 12 times and we've ended up in this position here. So we're actually still short. Why is that? Now this is super important to understand because we actually spend 2 moves on the square where our gem is. So if we count again, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's why we've ended up on this particular square. So if we continue counting, it's 12, 13, 14, 15. So you think 15 is the magic number. So let's give it a go. We'll run the code. Let's run it a bit faster this time. But guess what? We still haven't collected our last gem. That's quite interesting because we counted 15 steps. Do you know why we're missing the last gem? Have a guess. It's actually because on our very first square, we're already looping. So we need to count the first square as 1. Then we go 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then 16. So that's why we need to change the 15 to a 16, which was the original number that was provided to us already. And this should work. Let's test it out. Collecting 1 gem, the second gem up the stairs, the third one, and then collecting the last one. There we go. Congratulations, we've solved another puzzle. Now this one was especially important to understand why the number was 16 because it can trick a lot of people up. Let's now move on to the next challenge. This challenge is called Defining Smarter Functions. So what we're going to do is use all our skills that we've learned with functions, loops, and conditions to try to activate all the switches and collect all the gems. Now let's run this code to understand what happens first. Notice how the gems and the switches can change and be at any location they want. Here we've got 3 gems and 3 switches. If I run the code again, I've only got 2 gems and 4 switches. And out of the 4 switches, one of them is turned on. If I run the code again, it randomly changes and the position changes as well. So this can get quite tricky. But with our programming skills, we should be able to take this on, no problems. So the first thing we want to do is look at the function. It's called collect or toggle. So let's use the skills in the past to create this function. When we reach a tile, we need to check if is on close switch. Let's go ahead and toggle. Else, if is on gem, let's collect the gem. So this is our function called collect or toggle. So the first thing we want to do, can you guess? Move forward. Great. How many times? 2 times. And then we simply just call our function, collect or toggle. Of course, we could use the if statement into our main code, but putting it into a function makes it a little tidier and easier to understand. So let's test this first. We're going to move forward 2 times, jump into our function. Is it a close switch? No, it's not. Is it a gem? No, it's not. So we just do nothing. Now, what do? We actually need to move forward 2 times and collect or toggle again. So let me just copy this code here and paste it here. And we'll run this. Here we go, moving forward 2 times. And then another 2, it's a gem, so let's collect it. Excellent work. You can probably guess that we need to turn left, move forward 2 times, and then turn left, and then continue. Now, note that the space between each item is always 2. So before we turn the corner, let's first look at our code. Here, this is a repeating pattern. So what do we do with repeating patterns? We put them in a loop. Exactly. So let me go for, and then I'll go in the code. I'm just going to drag this down and then tidy this up and delete the extra code down below. And how many times do we want to repeat this? 2 times. Now let's run the code and check that we can still collect all the gems and toggle all the switches in our first row. Here we go, collecting the gem, moving forward, collecting the gem. That's it. So we've converted our code into a for loop. Now let's go ahead and turn left and then move forward again. How many times? 2 times. And then we can turn left. Let's run this a little faster and see how it works. Collecting the gem, turn left, move forward, turn left. Okay, now we are ready to solve the second row here, but the secret is we can just copy the first code in our for loop and repeat it. So let's copy this loop and try this, because we basically have to move forward 2 times and decide if we want to collect or toggle, and then move forward again. So let's run this. Toggle the switch, collecting the gem, and now we're going to solve the second row. Look at that. Can you guess what we need to do next? We need to turn right, move forward, and then turn right again. And then we're in a great position to do what? Well, we can use our for loop again to collect or toggle on the very last path. So let's run this and give it a test. Now we turn right, move forward, turn right, and look at that. Well done, future coders. It seems like you're really getting it. Using a function that contains an if statement, like we did up top here, is another way to make your code both reusable and adaptable, because you can call the function over and over again. Let's now move on to our next challenge. Now this challenge here is called boxed in. Here we want to continue using conditions, functions, and loops. So for this challenge, Byte is surrounded by a grid or lots of squares with gems or switches. We need to figure out how we can solve this puzzle in the most efficient manner. If you're not sure where to start, click on the hint and you can see that any tile in the square could have a gem or an open or closed switch. So let's first write a function called checkTile. And inside this function, we want to go if is on close switch. Let's go ahead and toggle the switch. Else if is on gem, we'll collect the gem. Nice and simple. And then in our main body, we want to go and move forward and then call our function called checkTile. So let's first give this a test. Step through the code. We'll move forward. Check the tile. Are we on a close switch? No. Are we on a gem? No. Then do nothing. Notice how all the gems and tiles are randomly placed as well. So next up, let's go ahead and we want to turn left. And then we want to move forward. And guess what? Check the tile again. So let's do this. Let's run the code normally this time. Moving forward, check the tile. It's a gem, so let's collect it. Let's move forward, check the tile. It's off. Let's turn it on. Now we can continue around this by turning left and then moving forward and then checking the tile. In this case here, we don't turn left anymore, but we have to go straight and check the tile as well. So this is where it gets a little bit tricky, because what we can do is continue walking normally around the side and just calling our function. But there's a smarter way. If you look closely, we could either walk along the edge in a loop, or we could walk from the center of the square to the other center, also in a loop. Now, what do I mean by this? Let's go ahead and say we've got a loop, and then we want to put all of this inside the loop. But let's first of all rearrange this so it becomes a clearer pattern. Let's take move forward and we'll put it on the outside because we want to start in the right position. So let's move forward and then turn left. Okay, we'll do that. In fact, let me delete this and let's run the code to see our starting position. Move forward, turn left. Now we want to go and do what? We want to check tile, move forward, check the tile, and then turn left. Then we want to move forward and then stop. That's all we want to do. So let's run this code and see what happens. So we get into position and then we go check tile. Yes, we move forward, we check the tile, great, turn left, then we move forward. But we don't check the tile yet because I want to go back to the top of the code and then check the tile. What this means is I can put this magically into a for loop, and you'll see what I mean. Let's repeat this maybe 2 times. Let's step through the code slowly because it is a bit tricky. We move forward, we turn left. Now we're in our loop. Let's check the tile. Does it close? Yes. Turn it on. Now we move forward. We check the tile again. We're on a gem, so let's collect it. Turn left, move forward. Now we go back to the top of our loop, check the tile, we toggle the switch, continue to move forward, check the tile, turn left, and move forward. There. Now whenever we move forward into this center location, we don't check the tile yet until we start the next loop. So now if I turn this to 4 and run through the code faster, we should be able to complete the challenge. Look at that. Great stuff. Now it's a little tricky, so you might have to recheck this again, but we have completed this puzzle in the most efficient way possible. So you've come a long way learning conditional code, combining all your skills with functions and loops. Let's now move on to our last challenge of this section. This challenge here is called Decision Tree. Here we need to collect the gems and toggle the switches along the center platform. But as you can see, there are several paths that take us away from it. So we need to use conditional code to detect whether the character is on a gem or a closed switch and take the appropriate or the right actions. Let's first look at what we need to do. We need to move forward and collect this gem. Now, if we're on a gem, then we need to turn right, go down this path, pick up this gem, and then come back to the center path. Then when we move forward, whenever we hit a closed switch, we know we need to toggle it on, and then we need to turn left and pick up that gem. And this pattern repeats down here as well. Notice that if I run the code, the positions don't change. So it's not like the other puzzles where they randomly appear in different locations. Here they are fixed. So as always, to tackle this puzzle, let's start off simply by moving forward and collecting the gem. Now let's go ahead and turn right. We want to move forward. How many steps? Let's go 1, 2, 3. So let's go move forward, and then we want to turn left, move forward, and then collect the gem. That's going to allow us to solve for the first part. Let's run the code and test this out. Collect the gem, go down the side path here, and collect this gem as well. Excellent. Now we've got to make our way back to the center path. So let's go and say, we don't have a turn around, so let's turn left 2 times like we've done in the past. And then we'll move forward. And which way do we turn now? Well, if we swing this around, we need to turn right and then move forward 3 more times to get back up to the top. And then we turn right to get back on the path. Let's test this out. Perfect. Now, if you look at the sample code above, you'll notice that we have a for loop where we move forward, just like here, and if we're on a gem, here we've got solve the right side. So basically, this is a function that's been created. So we can do the same thing. Let's go and create a function. Let's call it solve right side. And we can take all of this code down here. Let's cut it, paste it here, and then we'll go solve right side. There we go. This will give us the same result. Next, can you guess what we need to do? We need to move forward, and then we need to toggle the switch, and then collect the gem on the left side this time. So let's go turn left, move forward, collect the gem, turn left, move forward, turn left. And this will take us back to our main path facing forward. You don't believe me? Let's give this a test. There we go, we're facing forward again. Perfect. Now, if we look at the example, we've got solve left side. So we can create another function called solve left side. function, solve left side, and put all of this code in there as well. Let's cut and paste it, and then we call it solve left side. Now, we should be starting to see a pattern here because we need to move forward 2 times, and then guess what? Solve the right side. And then move forward and solve the left side. So we can do this the long way, just by typing it out, or we could use a loop. There we go. So here we've got 1 to 5. The reason why there's 5 is because we've got 5 squares on the main path. 1, 2, 3, 4, 5. So let me go ahead and create a loop for, and then I'm going to say, let's move forward. And if we're on a gem, if it's on a gem, we want to solve the right side. So let's take this guy, put it in here. Else, if is on a closed switch, we want to solve the left side. Let's delete this part down here. Now, let's put number 1 to 5 inside here, and let's give this a test. Solving the left side here, going back to the main path. Okay, so we notice we've got a bug in the code. So what has happened? We move forward, and then we solve the right side, and then we move forward again, but we've actually moved forward 2 times because we've got a move forward here and a move forward here. That's why we move forward to this square and then we move forward again. So we actually need to delete this move forward. Let's test this out. Here we go. Down the right side, move forward. The left side, moving forward, right side, and then the left side. There we go. So we had a small bug in our code, but we found the bug and we finished this section. Now this was quite a hard challenge actually. And if you look back, we can go ahead and make this code a bit better. Do you know how? For example, you could take the 3 move forwards and convert that into a function. So with that, give yourself a pat on the back and I'll see you on the next challenge.